should I get started? Or?
Yeah, so we can, yep, so let's get started. Feel free to start your screen.
Let me know when you can see my screen.
Yep, perfect.
Okay, so hey guys, I'm really excited to be here today. So today we will just be a relatively quick introduction to band protocol and our oracles, how they are currently being used in platforms such as Mirror Protocol and the Terra ecosystem, as well as how other developers can use the price data themselves. And just to quickly introduce myself as well, as Edgar said, I'm Sawit, and I'm currently the integration lead at Band Protocol, where I mainly oversee the partnerships and usage of Band oracles across the various dApps and blockchain platforms. With that out of the way, let's take a look at what we will be covering in more detail. We'll start off with a quick introduction of what Band Protocol does, how it's being used in the Terra, as well as some of the key features that when it comes to our Oracle. Then we'll move on to the more technical side, going over our Oracle on Terra, specifically how to query stock prices from it, both through Cosmos and smart contract, as well as through the Terra RPC endpoint. Finally, for those that are looking for a larger set of Oracle price data support, we will be taking a look at how to request price data from Band's Oracle ourselves and to make that data available to smart contracts on Terra through your own Oracle smart contract. First, Band. In short, Band protocol is a cross-chain decentralized data oracle, helping bridge and bring off-chain data onto blockchains for developers and smart contracts to have access to. Currently, we have integrated with a number of chains to have our Oracle service available to anyone building on them. These include chains such as Ethereum and Binance Smart Chain, Matic and Polygon, as well as Phantom and of course Terra. With Terra specifically, as some of you may know, we are the main Oracle provider being used to power Mirror Protocol. What we are doing is for each of the M asset, a number of our validators who run our chain, Band chain, goes out and query the price of the asset from multiple data sources. The reason that we use multiple data sources and multiple validators is to ensure maximum redundancy and robustness in case some of the data providers or validators fail to respond or provide an incorrect value. Once we have the price data from the validators, these values are then aggregated and minimized in order to remove any outlier or error values. The final result is then the aggregated price value that anyone can access and use in the applications. Mirror CDP's smart contracts then use these price data in their mechanism when minting and burning M assets, when calculating the collateral ratio, along with during the liquidation process. Of course, these prices on our smart contracts are also available for all developers to use. This can be done in two main ways: through the smart contract level, as well as through the endpoint from Terra. To query prices from Terra's endpoint, you need to call our Oracle contracts get reference data method and specify the base symbol and quote symbol that you would want to query. In this case, we will be querying the price of coin in USD denomination. The return data will then consist of three components: the rate, which is the price value of the pair multiplied by 10 to the power 18. The last updated base, which is the timestamp at which the base symbol, in this case coin, was last updated on the contract. And the last updated quote, also the timestamp at which the quote symbol price, in this case USD, was last updated. You can also query prices for multiple price pairs at the same time, using the get reference data bulk method instead. The inputs will then be the list of base symbols and quote symbols that you're looking to query. In this case, we are querying the price of Tesla and coin, both in USD denomination. The result of the call will then be a list of objects with identical fields to the previous case, with the price and last update timestamp for each pair. The same two functions are also accessible through our Oracle smart contract. And here is just the list of contract addresses for both the Tikla testnet and Columbus mainnet. To see how we can use the price data on the smart contract level, let's take a look at an example smart contract. Here we have a simple price database contract with two main functions. First, we have save price, which queries an asset's price from our Oracle contract and saves it onto the database contract state. And there's also get price, which then allows anyone to query the last save price of an asset from the simple database contract. When it comes to the implementation, what we did here is during the contract's initialization, we set a variable initial Oracle ref to be the address of Band's Oracle contract. Then when save price is called, we use this Oracle contract address to call the get reference data method, similar to how we did it using the API. Once the Oracle contract returns the price value, that value is then saved and stored into the state of the contract. Finally, note that in all of the previous example, the base symbols have always been in USD. However, it can actually be any other assets that the Oracle contract support and have the price data for. Let's say that we want to query the price of Tesla in coin denomination. In that case, we can just call get reference data with Tesla as the base symbol and coin as the quote symbol. If you then look at the result, you'll see that the rate comes out to about 2.3 coins per Tesla, and the timestamp the values when the prices of the assets are last updated on chain. In some cases, however, you might also like to query prices that are not available on our official contract. In that case, you can deploy your own simple Oracle contract and set up a custom price feeder to pull data from Band chain and feed the prices to your own smart contract. For the data available, we have what we call our Band standard dataset, which allows anyone to query the price of more than 100 cryptocurrency foreign exchange rates, as well as commodities easily from our Oracle. To find the list of assets that we currently support, you can go through data.bandprotocol.com. For how to actually retrieve this price data, the simplest way would most likely be through our REST endpoint. This diagram then shows an overview of how the feeder works. It starts off by querying the Band's endpoint to get the latest price from the specified assets. It then sends the transaction onto the Terra network, calling out deployed simple Oracle contracts relay method to update the price value on the contract. Finally, the feeder calls get reference data to check that the price has been updated successfully. Finally, let's take a look at an example implementation of the feeder. In this example, we will assume that we have a previously deployed Oracle contract with address std contract address. The main flow of the feeder itself then consists of 4 main steps. Query the latest token prices from Band chain, then create a message execute contract instance and get a signed transaction ready to broadcast. Then we need to broadcast the transaction onto the Terra network and wait for the transaction to be confirmed. Finally, we'll query the price of the price from the Oracle smart contract to confirm that the price data has been updated successfully. Let's go over each of them in a bit more detail. First, we start off by querying the latest token prices from Band chain. This can be done through the REST request prices endpoint on our REST API. In this case, we will be querying the prices of Bitcoin, ETH, and Band. If you then try to query the prices yourself, you'll see that the endpoint returns 4 fields for each of the token queries. The symbol, which is simply the token symbol that the other values in the object are related to. The multipliers, which is the amount that the price value was multiplied by. The PX, which is the latest price value of the token. The resolve time, the time that the price data was last updated on our chain, as well as the request ID, which is the ID associated with the request on Band chain. If you then take this request and try to look it up on our Cosmos-Scan block explorer, you also see more information about the data request and aggregation process that goes on for each of the price data. For example, if we then take this request ID for Bitcoin, you will see a couple of things. At the top of the page, you'll see the validators on our chain that responded and went out to retrieve the price data for this price query. You also see that the Bitcoin price is, in this case, updated along with the prices of ETH, Mirror, as well as Anchor. The page also shows the sources and data providers that are used to aggregate the price of each token. You can see that these include both exchanges such as Binance and Coinbase Pro, and aggregators such as CoinGecko and CoinMarketCap. Finally, you also see what each of the validated data responded for each of the data sources that they went out to query. Now that we have the price data ready, we can then prepare to update the price value on our smart contract by using Terra.js to create a new message execute contract instance. In that message, we are calling the contract's relay function. Once we have the signed transaction broadcasted, we then wait for the transaction to be confirmed, then try to query the latest price on the contract for the 3 tokens by calling the getReferenceDataBlock method, the same as what we have done previously through the REST endpoint. With that, your smart contract now has access to the 3 cryptocurrency prices through the Oracle contract that you deploy. Of course, I'll be sharing the link to this presentation at GitHub repository, which includes example code for both the simple Oracle smart contract as well as the feeder, as well as other links and resources related to our Oracle and other sources that I think will be helpful to you guys. But that's all I have for today. I'm happy to answer any questions that anyone might have, or go over something that I might have glossed over too quickly.
Mm-hmm. All right, thank you so much. While we wait for to see if anyone has questions, I have a few questions myself too. So if a developer is looking to implement an Oracle, especially for the first time, do you have any recommendations? So some of the important things to keep in mind?
I think there's a couple of things, right? One thing would be where if we were to use this in, say, a production environment, one would definitely be where you pull the data that you'll be using from, like the reliability and trustworthiness of the data sources and how reliable the data that they're providing are, as well as the, let's say, the robustness of the endpoint or the source that you are pulling from, because in the case of what we are doing with Mirror, we are pulling from multiple stock data providers to ensure that, let's say, if one of them provides an incorrect value or one of their API happens to go down or goes into maintenance, the Oracle price feed is still operational and it wouldn't affect the protocol or the functionality as a whole. And the other would be how frequently, in case of more fungible and more interval price data updates, such as token prices and crypto prices and other numeric data, right? How often you are looking to update those prices on chain, and how often do you really need to update the values? Because of course, right, having a more updated values, for the most part, we will have a lot of benefit in case of sudden market movements or sudden changes in the price value. But there's also other factors that you need to be more concerned with, especially in production and in the mainnet, such as the cost of feeding the data and the reliability of the infrastructure of what you're using to feed the data. Because the faster you're feeding the data, the more likely issues such as, the previous transaction not being confirmed and you're already broadcasting a new transaction, and how you're handling those edge cases, those will definitely come more into play from what we have we have experienced during our time supporting the apps and blockchain platforms.
All right, perfect, absolutely. Yeah, so and we have a few questions here now. So the first question is, how can we help get new things added to the Oracle? For example, sport games, charity data, and so on.
So generally, like, right, our Oracle definitely supports a lot of data other than stock prices and crypto prices and other price value-based data. And we have also, integrated support for a lot of insurance platform, including, providing data related to the flight status and whether the flight was delayed. But, in the scope of this hackathon, at least, those processes and those custom Oracle typically take quite a lot of time for us to implement. And due to the short nature of the hackathon being only 3 to 4 days, what I think I would recommend is, once I think what the developers can do is take the Oracle contract that I'll be sharing later after the workshop as an example, and modifying it to fit the data that they will be needing, and feeding the data themselves for their product during the hackathon. But if anyone is looking to extend their product and looking to develop this into a real product that to develop it further after the hackathon, we would be more than willing to help out on the providing the data and implementing a custom Oracle for those developers to use afterwards.
Yeah, perfect, thank you. Yeah, and if anyone needs to have a contact, the contacts can be shared. So feel free to ask in the chat, and I believe they're more than happy to help implement new sources. And okay, so next question. Could you maybe go over the difference between the two methods for acquiring price? One was to get the latest price, and I think the other saved value in smart contract, if I recall correctly.
Oh, so the first, I think there are two cases, right? The first was what we have already on hand is the stock data or stock price Oracle that is already live on, that has an associated smart contract that is live on both the Terra mainnet and testnet, that is being used by the Mirror team themselves. So anyone can query the prices from that directly using the get reference data method or the get reference data bulk method, as I was saying. But the second, the Oracle contract that is related to the having to save the price yourselves and query the price again, that was just an example of, let's say, if you were looking to use the Oracle smart contract, it was just a simple price database contract that shows how to, let's say, save price data onto the contract state, and for other contracts to then query the price from that example contract. So it just shows the possible instructions and how you would go about implementing querying prices from our contract. That smart contract was not meant to be, an Oracle contract in of itself.
Perfect, thank you. Okay, so third question we have. We are building a prediction price platform for Terra assets. We want to use prices at a certain time frames. I assume that we need to query banned Oracle price to obtain the exact price to deliver the pot to the winner, right?
Yep. So right now, the standard data set and the stock prices that we are providing on Terra, right, is updated on more of an interval basis. So there's two ways that you can, to answer the question, there's two ways that you can go about implementing that. One would be, as they said, query the price at the correct time. But the other one, that might provide you with a more accurate value, is to send a transaction onto Bandchain yourself to request the data when at the moment that you need it, and then retrieve the price data and update and use that price data in the contract yourself. And as for the second option, right, with sending request transaction, I can provide like an example code or example script to do that as well.
All right, perfect. So we are out of questions. I'm going to ask you one question from my side too. It's going to be quite a newbie question, but have you identified, so what are the some of the biggest challenges you've seen from developers who are trying to implement an Oracle? Are there any specific things that you've seen that the developers are usually challenged by?
Would you happen to mean like for what's challenging for developers looking to integrate price feeds, right?
Yeah, especially again, especially if they're doing it for the first time. So what are the biggest like challenges that they run up to, or is it pretty much like a smooth road to implement it like from the first time?
I think previously, right, I think there was definitely some issues and some room for improvement that we identified. The first was let's say when you're looking to query multiple prices, the previous implementations that we have and other oracles have is having separate contracts for each of the price feeds, which means you need to maintain a list of the list of contract addresses that you might need, which for most people is not really that intuitive, as well as price data support for the less well-known tokens and less used tokens, and especially new tokens, given the state of this bull run and the fact that there seems to be basically a new token every day. So that's why we came up with a simple solution such as the bandstat dataset, where we try to query, where we try to make available as many cryptocurrency and token prices as possible, as well as having those available all through a single interface. So, and for any of the assets, you would need to just call one script, one contract, as well as using just the same method for all of them. And it also, on our side, that we also make it a lot easier and faster for us to be able to implement new feeds and get new price token up and running for any partners that are looking to support either new or less well-known, less commonly seen or implemented token.
Okay, amazing, thank you. All right, so we've run out of questions. I'm going to ask you a fun question, just to give a few more minutes in case someone wants to ask another question. How much sleep are you getting in this bull run?
Honestly, not too bad, but not not quite optimal either, to be fair, because a lot of projects, given this bull run, right, people are definitely trying to how do I say this, to keep up with the pace of the innovation and development that's going on during the last few months. So a lot of and there's certainly a lot more attention on DeFi and a lot more people being more active in the community. So with the platform we have worked with, we have seen a lot of requests to add new tokens to their protocol, which also means that we need to add support for new tokens, as well as a lot of impromptu with some of the as well as issues that arise with network congestions and traffic that we need to develop and workarounds for to make sure that our Oracle price feed maintain their 100% uptime and consistency and reliability as well.
Okay, got it. Thank you. We got one more question. All right. What's the best way to reach out after the hackathon if we get to the incubator?
So you can definitely reach out to me through Hackathon, through my Telegram, right? I will send a message in the Hackathon chat with all the contact info and the resources and the other links. And I think if that might be, and if in case the message gets drowned, I think Edgar, do you mind helping, possibly connecting the team as well?
Yep, absolutely. So I will make sure that the contacts will be shared, and I will also help that in case you'll have difficulties with getting hold of Sawit, then I'm happy to help. But yeah, we will share.
And during the hackathon itself, right, I'm always available if anyone have any questions regarding the Oracle, or, you know, if, let's say, in reference to the previous question, if they're like looking to implement their own data feeds that might not be exactly price token feed, such as, you know, sports score or other metrics, I can help in terms of how to structure and how to design and implement that as well.
All right, cool. So looks like we've answered all the questions, and we can wrap it up. Thank you so much, Sawit. It was a very interesting presentation, and it looks like people learned a lot too, and we had some great questions. And thank you for the participants.
Yep. Thank you, Edgar, for, you know, organizing all of this, and thanks to the others as well for joining and sending in questions. And as always, you know, as I said, let me know if I can help in any way during the hackathon. Always on standby to assist.
All right. Thank you all. And I'm going to upload the recording soon after. All right. Ciao.
Thank you.